One major goal of statistics is to be able to gather data, analyze it, and then use it to make decisions. Often, we're only able to collect data from samples, but we would like to use that data to be able to make conclusions about the entire population. In order to be able to do that, we need to understand the concept of the central limit theorem. First, let's go over a little bit of notation. I'll use a capital X to represent the original random variable, and this random variable can have any distribution. Uniform, exponential, skew, doesn't really matter. That random variable is going to have a measure of center like the mean. So we'll use mu sub capital X to represent the mean of the variable x. It'll also have some kind of spread, like our standard deviation. So sigma subscript capital X will represent the standard deviation for our random variable capital X. And then we have capital X with a little horizontal bar above it. That is a new variable. It's related to the other capital X, but it's not the same thing. And it doesn't have necessarily the same distribution as capital X. We've seen x bar before. Little x bar, a lowercase x with a bar over it, and that represented a statistic. It was our sample mean. Well, capital X bar is a set of sample means. So imagine that you have your data set capital X, our random variable with some distribution. I can take samples from that data set and calculate the mean on those samples. All of the means that I can calculate collected together, that's what this capital X bar is. So the set of sample means found in random samples that I have collected from the data set X. The size of those samples that we're collecting is determined by n, so that's the size of each of these random samples that we've used to create the variable x bar. Now that we understand this notation, let's take a look at what the central limit theorem tells us. No lemons involved. That this new variable, capital X bar, the set of sample means, will follow a normal distribution. Not only does that tell us what shape the distribution follows, but it'll also tell us the mean and standard deviation for this new random variable. So let's say we talk about a random variable, capital X, and we know the mean and we know the standard deviation for that original variable, capital X. If we would like to, we could take random samples, calculate the means, form a new variable, capital X bar. It will have a normal distribution with the exact same mean as the original variable. Notice here I'm saying that capital X bar follows a normal distribution with the center at the exact same number as the mean from the original variable. Also, the standard deviation takes into account the original variable's standard deviation, but it's not equal to it. We have to take the original standard deviation for capital X and divide it by the square root of our sample size, so dividing by the square root of n. So for any random variable x, if we know the mean and the standard deviation, we can create a new variable, x bar. That new variable will follow a normal distribution with the same mean as the original variable and a slightly different standard deviation, but not one that's too hard to calculate. So in short, the central limit theorem starts with taking samples. So let's assume we take 3 samples. It's not a lot, but anyways, for each one of these samples, we need to calculate the sample mean. So if we took 3 samples, I would then calculate the mean for each one of those samples. I would have 3 sample means. Together, those 3 sample means form a new data set. So I take my samples from the original data set, calculate the means, and form a new data set. That new data set is the capital X bar. And that new data set is going to follow a normal distribution. That bell-shaped curve with the center right at the peak. And on our pictures, we would then draw our horizontal axis as the different values from our sample means. So I'm using a lowercase x bar with a subscript I. That I is just representing that it can go to any one of the samples we've taken. So if I was 1, then it would have came from sample 1. If I is 100, then it came from the 100th sample. I'm also pointing out here that the center of this distribution for x bar is exactly the same center as the original random variable. So the sample means, the lowercase x bar, target the population mean. And as our sample size gets larger and larger, we get even closer and closer to the population mean.